self-induction and mutual induction. Self-induction or self-inductance is the property of a coil by virtue of which the coil opposes the growth and decay of the current in it. Experiment to demonstrate self-induction. Let us perform an experiment to understand this. Connect two bulbs B1 and B2 of same wattage to a resistor and an inductance coil respectively as shown here. Press the key K. What do you observe? We observe that the bulb B1 glows immediately to its maximum brightness, whereas the bulb B2 takes time to glow brightly. This is because the flow of current through the coil of inductance L generates an induced EMF which opposes the current. Thus, B2 glows slowly. However, no induced EMF is developed in the resistor R, and hence the bulb B1 glows to its maximum brilliance instantly. Now observe what happens when the key is released. We observe that B1 stops glowing immediately, whereas bulb B2 takes some time to stop glowing. This is because an induced current is set up along the direction of current from the battery, and this delays the process of decay of current. Mutual induction. The phenomenon of production of induced EMF in one coil due to change of current in a neighboring coil is called mutual induction. Let us perform an experiment to understand this. Place two coils P and S close to each other as shown here. Connect a battery and a key to the primary coil P and connect the secondary coil S to a sensitive galvanometer G. Whenever the key is pressed or released, the galvanometer shows a deflection. Now observe the deflection of the galvanometer needle by pressing and releasing the key. The needle deflects because the current flowing through the primary coil induces a current in the secondary coil. How does mutual induction occur? When the key K is pressed, current starts flowing through the coil P, and this increases the magnetic flux linked with P. Since S is very close to P, the magnetic flux linked with S also increases. Thus, induced EMF, hence induced current, is produced in S. The direction of induced current in S is given by the arrow marked 1, in accordance with Lenz's law. Similarly, when the key is released, magnetic flux associated with the coils decreases, and this gives rise to induced current in the direction shown by the arrow marked 2. That is, mutual induction is the production of induced EMF in the secondary coil during the time of make or break of current in the primary coil.